Okay, let's continue with our directional derivative series, and let's talk about the directional derivative of our function given in the direction of the vector v at the point 8, 0. So we have g of uv is equal to u squared over e to the v. Our point is 8, 0, and our unit vector, well, not our unit vector, our vector is 3, 4. So to find, first of all, the directional derivative in the direction of v, now we can write it like that, but again, we're only worrying about the direction of the vector, not the magnitude of the vector. And so we can find a vector that is equal to the, well, it has the same direction as v, but not the magnitude, it has a magnitude of 1. That would be vector u, but I can just write v here for now. And then function, it's not f, it's g, u, comma, v. And v is not, well, these v's are not the same, by the way. So again, just to be clear, this is a v that represents the independent variable, and this is a v that represents the vector. Is equal to the gradient g u comma v dot product with the unit vector. And obviously the unit vector is going to be the magnitude, sorry, the vector v over the magnitude. So that's basically what this is going to be. Okay, let's find the gradient first. The gradient is going to be the partial derivatives. So partial g with respect to u, v, comma, partial g with respect to v, comma, v. First of all, partial g with respect to u is treating the, sorry about that, so many mistakes. V is a constant. We have 1 over e to the v times 2u, which is 2u over e to the v. Partial derivative with respect to v is going to be equal to, treating u a constant, so we have u squared, and then times e to the negative v times negative 1. Negative u squared times e to the negative v. Or, of course, even better is negative u squared over e to the v. Okay, so now let's write the gradient. Two u over e to the v, comma, negative u squared over e to the v. That's pretty much the gradient, and then we can plug it in at a point 8, 0. So it's 2 times 8 divided by e to the 0, comma, negative 8 squared over e to the 0. That is 16, comma, negative 16. Sorry, negative 64. Okay, now let's find the unit vector u, which is going to be the magnitude, 1 over the magnitude times the vector of the vector v times the vector v. So the magnitude of the vector is 25, I'm pretty sure. Sorry, 5, not 25, 5. So this is 5. And then we have, so this is going to be u is 3/4 over 5. Three-fifths, comma 4/5. So finally, directional derivative. In the direction of u, same thing. It's in the direction of v, because they both have the same direction. G u v is equal to the gradient dotted with the unit vector, just u. So this is going to be equal to the gradient, which is 16 negative 64, dotted with 3/5, 4/5. Just 16 times 3/5 plus negative 64 times 4/5. Alright. What is 16 times 3 over 5? Well, that is going to be, let's see, 48 over 5, right? Just to be sure, 48 over 5. And then minus, so 64 times 5, sorry, times 4 over 5. We have 256 over 5, but minus 256 over 5. And then just to subtract these two, we have 48 minus 256 over 5, which is, of course, just negative 208 over 5. And really, that's it. That is your slope, your directional derivative at that point in the direction of vector v of our function. That's it.